Hello, I'm Gary with HaveFunWithScience.com. I have a question for you. What do you think would happen if you take an ordinary ruler, position it so that 2 inches of it is overhanging the table, and then take 2 pieces of regular newspaper and lay it on the table and over the ruler, the part of the ruler that is laying on the table, smooth it out, and then take a big stick and hit it. Do you think that the ruler will break and that the paper will pretty much stay where it is on the table? Or do you think that the paper will fly up in the air and the ruler stays intact? What do you think? Let's find out. For those of you who guessed that the ruler would break and that the paper would largely stay in place on the table, congratulations! Why would the ruler break and the paper pretty much stay in place on the table? It's because of air pressure. Air pressure is literally pushing down on the table, on the newspaper, and to the point where when you strike the ruler with a fast and hard hit, it will actually break, as you just saw. But a ruler's pretty small. How about a real test? Do you think this would work on a big stick? Let's find out. Okay, a skeptic might say, alright, that worked on a little stick, like a ruler, but how about a real stick? Let's give it a try. For the next experiment, I'm going to use a piece of floorboard molding. You should recognize it. You have something similar to it at the base of your walls and above the carpet at your home. Now this board is 3.5 inches high, 36 inches long, and at its widest point, 3/8 inches thick. The procedure is the same as it was with the ruler, only this time instead of using 2 pieces of newspaper, I'm using 4. 2 pieces at the front of the stick, and 2 more pieces of newspaper at the back of the stick. As you can see, with the newspapers blowing around, there's occasional gusts of wind. To deal with that problem, I took some gravel out of the driveway to help weigh the paper down. It doesn't affect the experiment in any way, it just keeps the paper in place so I can conduct the experiment. Whoops, that didn't work right. The problem was I had too much of the board overhanging the table. Remember, with the ruler, there's only 2 inches supposed to be overhanging? You only need a small amount of the board overhanging the table. Now that's better. That's the way it's supposed to work. One more chop. There you have it. Just as with the little ruler, the same rules apply with the big stick, and it breaks too. So what is air pressure anyway? Air pressure is a force pushing down on an object by the weight of the surrounding air molecules. And all of those air molecules can add up to a measurable amount of weight. And on a piece of newspaper, we can measure the air pressure by pounds per square inch. So what is a square inch? A square inch, as shown here in silver, is a unit of area equal to a square where all four sides are 1 inch long. The newspaper I used was nearly 23 inches by 23 inches, so I rounded it to 23 to make the math easier. Now imagine that you are on an island and the sky is clear and the sun is bright and the waves are splashing elegantly against the white sand. And you're on the beach with the table and your stick and your newspaper and you're getting ready to strike the ruler. Now, the air pressure weighing down on the newspaper per square inch at sea level is 14.7 pounds on a normal day. So, what does that mean? Well, imagine that this paper right here is your newspaper, and that this pillar at the bottom is 1 square inch. Also imagine that this pillar starts at your newspaper at sea level and shoots clear up into the sky, piercing the clouds, and reaches to the top of the atmosphere. Now, inside this pillar would be air, and all the air molecules that are inside would be weighing down and pushing against this square inch on your newspaper. Now, all of that air from this square inch to the very top of the atmosphere in this column would weigh, on a normal day, 14.7 pounds. And since it's all weighing down on 1 square inch of your paper, you can arrive at 14.7 pounds per square inch. Now, that would duplicate itself with the next square inch, and the next square inch, and the next square inch of the paper. Now, my newspaper that I used for this experiment was 23 inches by 23 inches. To arrive at the area of the sheet of newspaper, you multiply the length times the width. Since they're both 23 inches, you multiply 23 inches times 23 inches, and you come up with 529 square inches. Now you take the 529 square inches per sheet of newspaper, and you multiply that by the pounds per square inch found at sea level, which is 14.7. And 14.7 times 529 square inches equals 7,776.3 pounds per square inch of air pressure pushing against the newspaper. Now, a U.S. ton equals 2,000 pounds. So if you divide 2,000 pounds into 7,776.3 pounds, there is 3.888 tons of air pressure pushing against each sheet of newspaper at sea level. And that is why the stick breaks and the newspaper pretty much stays in place. All of that air pressure pushing down on the paper is a tremendous force to counter. Now, just for comparison, I picked another point of reference, Denver, Colorado, and I picked it because of its nickname, the Mile High City. It is 5,280 feet above sea level. Now, if you've never been to Denver, it's unique in that the city is placed right in front of the Rocky Mountains. So Denver's on flat land, and then the mountains are right behind it. Now, the air pressure at Denver, Colorado is not 14.7 pounds per square inch. It is less. At Denver, Colorado, it is 12.1 pounds per square inch. So even in Denver, Colorado, you would still have over 3 tons of surface pressure pushing against the newspaper. The board should break under the newspaper there as well. By the way, there is another way to measure air pressure other than pounds per square inch. You can also measure it by barometric pressure. Now, the equivalent barometric pressure to 14.7 pounds per square inch is 29.92. And the equivalent barometric pressure to 12.1 pounds per square inch is 24.63.